Welcome back. Previously, we used the concepts of point-slope form and slope-intercept form and applied that to different scenarios. Essentially, we would be given a couple of points or a slope and a point, and we would calculate the equation of a line in slope-intercept form or point-slope form, or sometimes we would even put that into standard form. Now we're going to find a different way to, or give you a different way to find a slope and a point and then come up with an equation of those lines and then use that equation to find some additional information. Okay, so in our word problems here, we'll have a slope and a point built in, or we'll give you two different points, and then you can calculate using our skills learned previously. You can calculate the equation of the line and then use that equation to find additional information. Other information you'll need to recall is the concept of the dependent and the independent variable. Okay, our dependent variable is our y and the independent is the x. We've talked about that y, our y depends on x. Okay, so our x is independent and our y is dependent. So in our first example here, the new iPhone is advertised to sell for $200 plus a monthly fee of $80. Well, what depends on what here? Well, in this example, our cost of owning an iPhone depends on, I'll just write DO, depends on the number of months that we own it. Okay, so if our cost depends on the number of months, our cost is dependent on months, so cost Y depends on X. So now we know that our X is months and our cost of owning the phone is Y. So my independent variable is not cost, it is months. And my dependent variable is cost. Okay? So my cost depends on the number of months. So we want to write the equation of a line that represents this scenario. So this is costing us $80 every month plus a fixed cost of $200 for buying the phone. So my cost, Y, equals $80 per month, 80 times X, plus 200. So there's the equation of my line. Now I can use that equation to calculate the cost of owning the iPhone for 10 months. Well, 10 months, we know that's an X. So I actually have half of my ordered pair here, 10 something. I have an X value, and I want to calculate the cost, which is Y. So using my equation, Y equals 80 times 10 plus 200, a little arithmetic here, 800 plus 200, and we get Y equals 1,000. So after 10 months, it costs me $1,000. And so that's my ordered pair, 10, 1,000. For 10 months, it costs $1,000. Now I can also use the equation to calculate the cost of owning the iPhone when it reaches $2,600. So now my cost is $2,600. I want to calculate when that happens, the number of months. So I don't know my X here, but I do know my Y. So in this situation, using our equation, 2,600 Y equals 80X plus 200. So I have my Y, so I'm working with the ordered pair something, 2,600, and I'm trying to find the X value. So I'll subtract 200 from both sides, and I get 2400 equals 80x. I divide both sides by 80. See how I use my equation? I let my algebra do the work for me, and x equals 30. So I know that after 30 months, or 2.5 years, my iPhone's going to cost me $2,600. That's a lot of money. It better be worth it. Let's do another example. Cleary's purchased a used Toyota minivan, a 12-month-old Toyota minivan for $20,000. When the van was 30 months old, its value was $11,000. Determine your dependent and independent variable. Okay? Well, the value depends on the age. Okay? So in this case, if the value depends on the age, my independent variable is time, or the age of the van, or months. And my y is the van's value. I know that the value depends on the age. So y depends on x. So my age is the x, or the months, and the y is the value. So if we want to determine the ordered pairs in this question, I do have some ordered pairs. At 12 months, my van is worth $20,000. And my other ordered pair, at 30 months, the value is $11,000. Now we want to derive a mathematical model. Well, all I have are these 2 points. Well, if we have 2 points, we can always calculate the slope. And if we can calculate the slope and we have a point, we're going to use point-slope form. So let's go ahead and calculate the slope. 20,000 minus 11,000, my change in y, over my change in x. So 12 minus 30. So that is equal to $9,000 over a negative 18. And that is negative 500 over 1. So my slope is negative 500. Substituting that into point-slope form, my point-slope form, y minus y1 equals m times x minus x1, and we want to substitute into the right-hand y and the right-hand x. And it doesn't matter which ordered pair we use. So I'm going to use the 12 and the 20,000. So y minus 20,000 equals negative 500. Better get that negative sign in there. Better stay. Times x minus 12. So y minus 20,000 equals negative 500x, negative 500x plus 6,000. I add 20,000 to both sides of my equation, and I get an equation of y equals negative 500x plus, add my 20,000, plus 26,000. So this is the value. Y equals negative 500x plus 26,000. So if you're paying attention here, you'll see that for every month, the van drops in value of $500. So we want to use the model to predict the value of the van when it is new. Okay, so we want to predict the value. We want to know what y is when it's new. Well, new is 0 months old. Okay, so that is my x equals 0. If you're paying attention, you'll see that that's the y-intercept. Y equals negative 500 times 0 plus 26,000. And sure enough, we get y equals 26,000. Okay, so that is our ordered pair, 0, 26,000. It's the y-intercept. So that was an eyeball problem. We could have probably just looked at that one. Continuing on, we want to use the model to predict when the Cleary's van will become worthless. Well, when our van is worthless, the value is 0. So now we're setting y equal to 0. So that's going to be the ordered pair something 0. And that is our x-intercept. So 0, y equals negative 500 x plus 26,000. Using our equation, we subtract 26,000 from both sides. And we get negative 26,000 equals negative 500x. Divide by negative 500, and you will see that x equals, my arithmetic is correct, x equals 52 months. So, wow, just a little over 4 years old, 4 years and 4 months, and the Cleary van is worthless. That's not good. If the Clearys want to sell their van for $8,000, when should they sell it? So once again, I have a value y. When should we sell it? That is our x. So we're working with the ordered pair something 8,000. So we have a y value, so we can substitute that into our equation. So now 8,000 equals negative 500x plus 26,000. I subtract 26,000 from both sides. I get negative 18,000 equals negative 500x. Divide by negative 500. And sure enough, 36 equals x. Oops, not 0, x. So 36 months. So if I want to get 8,000 for the van, I better sell it when it's 36 months old. Third problem. In an attempt to determine a correlation between the heights of American males at age 24 compared to their height at age 14, thousands of men were surveyed. The results found that a 14-year-old with an average height of 59 inches grew to a height of 67 inches by the age of 24. Furthermore, 14-year-olds with an average height of 64 inches were 76 inches tall by age 24. So, determine our dependent and independent variable. Well, this is a little tougher, but our dependent and independent variable, apparently our height at age 24 depends upon our height at 14. So how tall we are at 24 depends on how tall we were at 14. So y depends on x. So our x must be the height at 14, and y is our height at 24. Determine the ordered pairs. The results found that 14-year-old with an average height of 59 inches grew to a height of 67. So that's one of our ordered pairs. 59, 67. If you're 59 inches tall at 14, you grew to be about 67 at 24. And furthermore, 14-year-olds with an average height of 64 grew to 76 inches tall. So there are two ordered pairs. And we'll repeat that process again. We're going to calculate the slope, and then we will put our information into point-to-slope form. So, if we calculate our slope, we will calculate, we'll do 76 minus 67, change in y, over my change in x, 64 minus 59, and we get 9 over 5. Substituting in one of the ordered pairs, the numbers aren't real friendly here, but we'll manage to get our way through. So y minus 67 equals 9/5 times x minus 59. So we've substituted into point-slope form. We'll distribute our 9/5. Y minus 67 equals 9/5 x minus whatever 59 times 9/5 is, and we will see that is 531/5. 67, well, that is 335/5. So I will add 335/5 to both sides. It's just 67 in terms of fifths. 335/5. And we get y equals 9/5 x minus 196/5. So that is the equation of our line. So get that in your notes. Y equals 9/5 x minus 196/5. That is our mathematical model that we will use to do some more calculations as we continue with this particular problem. So now we're going to use our model to make a prediction. Okay, predict the height of a 24-year-old male if he is 62 inches tall at age 14. Well, remember our height at age 14 was our x. So we've got the ordered pair here, 62 something. We want to find out the y. So using our model from above, y equals 9/5 x. Oh, I have x. 9/5 x. So that'd be 9/5 times 62 minus 196/5. So 9 times 62 is 558 fifths minus 196 fifths, and we get y equals 362 fifths. Quickly with a calculator, I see that is 72 2/5 inches. So if you're 62 inches tall at age 14, you'll be about 72 2/5 according to our model at age 24. And we can do this in the opposite direction. Use your model to predict the height of a 14-year-old male if he was 65 inches tall at age 24. Well, this now is our y. We've got the height at age 24. So we've got the ordered pair blank, 65. And now we want to find the x. So using our model, 65y equals 9/5 x minus 196/5. I'm going to convert my 65 into fifths. That's 325/5. So I have a common denominator equals 9/5 x minus 196/5. I'm going to add 196/5 to both sides. So I can add those, and I get 521/5 equals 9/5 x. Solving for x, I multiply both sides by 5/9. So I'm going to write over here where you can see this a little better. So I have 5 over 9 times 521 over 5 equals 9/5 x times 5/9. So that's the property of our reciprocal, so that's 1x. Our 5's cancel, and we get 521 over 9 equals x, which simplifies to 57 8/9 equals x, or 57 8/9 inches. So if you grew to be 65 inches tall at age 24, you were probably about 57 8/9, about 58 inches tall when you were 14. So there are some examples of word problems and calculating information and making predictions using mathematical models. Mathematical models derived from point-slope form. We'll see you in class.